This episode of Drawing Lewis Structures is brought to you by thiocyanate ion. It has a fancy name and a formula of SCN with a 1- charge. And so we're going to draw the Lewis structure for this molecule. Okay, so we start with step 1, adding up the total valence electrons. Sulfur has 6, carbon has 4, and nitrogen has 5. So we'll add those up. And of course, again, we have a 1- charge, so we have to add 1 to the total. So we end up with 16 electrons that have to be represented in our structure. Okay, now typically, the element that's written first would go in the middle. Alright, and at this point, I wouldn't blame you for putting sulfur in the middle and the carbon on both sides. I will tell you that this one happens to be written in the order in which they're typically bonded to each other. So we're actually going to put the carbon in the middle. Now that you wouldn't have known otherwise, I'm just kind of giving you that information. In which case, you know, when that happens, you would have to be told that information. Otherwise, you would go on your original ideas. Alright, but let's put the carbon in the middle, because we know that that's what it actually does most of the time. And so we're going to add our single bond to both the sulfur and the nitrogen. So we have SCN just as it's written up here. So 4 electrons have been used, so we go to the outsides, and we add 6 more dots to each end to give the sulfur and the nitrogen both an octet. Now at this point, I've used up all 16 electrons, and I'm finished with step 3, so I go to step 4. Step 4 says any remaining electrons would go on the central atom, but again, I don't have any remaining electrons. So I scan over my molecule and I realize that the carbon only has 4 electrons associated with it, and it should have 8. And because I have a shortage of electrons, I'm going to do some multiple bonding to get the carbon up to 8. Okay, now here we have several options. Okay, the first option, and the one you might gravitate to first, is to take a pair off the sulfur, make a double bond, so now you have 2, 4, 6, 8 over here, and then do the same on the other side to make 2 double bonds. That keeps the nitrogen and sulfur both at 8, but also bumps carbon up to 8. And we've used 16 electrons evenly throughout the molecule, and it tends to be fairly symmetrical, as many molecules are, and that's great. You could have also, if I just redraw this real quick, taken a pair off the sulfur and made it a double bond, but then taken another pair off the sulfur to make a triple bond. So we could do a triple bond and a single bond, and if you're getting ahead of me, you might think, well, you could just do the same thing on the other end too, couldn't you? And make a triple bond on this side and a single bond on the other side. And any of those are going to be valid Lewis structures. I'm going to draw the brackets around each one. Any of those 3 would follow all the steps and be a valid Lewis structure, and they would also be resonance structures of each other. And in fact, electrons are always kind of moving around through the molecule, and if you have a chance to do a double bond in different places, you get this sort of oscillation where the electron can move back and forth, and maybe it looks like this for a while, but for a moment maybe it's over here with a triple bond, and maybe the electrons move over here and make this a triple bond. And so they're kind of always moving between the possibilities that they have for each other. Alright, and again, these are called resonance structures. Okay, so as we begin doing our Lewis structures, I would be happy with any one of those. Also, again, if you're asked to draw resonance structures, you know, draw them all. There is a way to determine which one of these is the most likely, but that will come in a later episode on something called formal charge.